Okay, so this is geometry 6-5, special parallelograms, rhombi and squares. Rhombi is the plural of rhombus. So rhombus is one. So I'm on page 460, section 6-5. We'll start out by talking about definitions. A rhombus is a parallelogram. Remember, this is the symbol for parallelogram, okay, with four congruent sides. Now, just to give you a rundown, a parallelogram has a lot of things. What can you tell me about a parallelogram? What are some things that a parallelogram has?
Two pairs of congruent sides.
Two pairs of opposite sides congruent, yep.
Opposite angles.
Two pairs of opposite angles congruent. Are the diagonals equal?
Yeah.
No. But what do? They bisect each other, okay? They bisect. And what about consecutive angles in a parallelogram?
Supplementary.
They're supplementary. Okay, all of these things then a rhombus has. Plus, a rhombus says all sides equal. You understand that? Okay, so a rhombus, if we look at it, if I want to add stuff to my notes, it looks like this. Okay? Now, there's two theorems. This is by definition. A parallelogram. You can't call it a quadrilateral. You have to call it a parallelogram with four sides congruent. Okay. Then, theorem one, the diagonals of a rhombus are perpendicular. So if I look here, AC is perpendicular to DB. So in other words, you have four right angles here. Four right angles. Okay? Now, once again, the diagonals are not congruent, but because it's a parallelogram, they bisect each other, right? So this is equal to that, and this is equal to that. Is that true? Yes, because it's a parallelogram. But this goes more than that. It says the diagonals bisect each pair of opposite angles. Okay? So what we have is, since this angle is equal to this angle is congruent to this angle, is congruent to this angle, is congruent to that angle. Right? Because opposite angles are congruent, correct? And then it bisects them, which means it cuts them in half. That also means that this angle is congruent to this angle, is congruent to this angle, is congruent to this angle. So those angles are congruent. And I wrote them all out for you, but it's always nice to mark it. Okay. Now remember, I'm going to say this again. The diagonals are not equal. They just bisect each other. Okay? They bisect each other and they bisect opposite angles. Okay? Any questions so far? Okay, so if this angle, this whole angle here is FJH is 82 degrees, okay? We want to find this angle right here. This is the angle we're looking for, KHJ, okay? How big is this angle right here? This one right here. It's what?
41.
41 degrees. Would you tell me why you know that?
Half.
It's half of 82, because that's what bisect means. Do you understand that? Okay. So if this is 41, how big is this angle here?
Which one?
This one here. JKH. This one right here. JKH. How big is that? According to this theorem right here,
90.
the diagonals of a rhombus are perpendicular. So this is 90. So how do I find this angle?
90 plus 41, subtract 180.
All right, 90 plus 41, and we're going to subtract that from 180.
139.
It's how much?
139, subtract 180.
180 minus, I think,
131.
131. Right? So this would be 9 and 49 degrees. Is that true? Okay. All right. Now I'm going to throw something else at you before we move on to the square. Bless you. I'm going to tell you that GH is x plus 9. The length of GH is x plus 9. And the length of JH is 5x minus 2. Now I don't want you to solve for x, but I want you to tell me how you would solve for x. If that's a rhombus, if this is a rhombus,
Oh, x plus 9 equals. Well, he said solve for
okay, go.
x plus 9 equals 5x subtract 2.
Is that what you would have said?
Yes.
Yes, why?
Because a rhombus is a parallelogram with four congruent sides.
All right, so these are equal, right? So I would take x plus 9 equals 5x minus 2, and then I would solve for x.
You say equals.
Yes, I would say this is equal to that, and then solve for x. Okay, because because in a rhombus, all the sides are equal. Bo, you understand?
Mhm.
Okay, a square goes much further than a rhombus. It is a parallelogram with not only 4 congruent sides, but it has 4 right angles. Okay, and we said, remember that we had the rhombus, right? And the square, the rhombus and the square on our initial diagram. The rhombus and the rectangle, sorry. The rhombus and the rectangle on our initial diagram, and we put those together and they make a square, right? So a square has all the properties of a parallelogram, the square has all the properties of a rhombus, and the square has all the properties of a rectangle. That's a square, okay? All right, now, there are 4 converses of those, actually 3, and then we added, actually only 2, and then we added a couple extra. If the diagonals of a parallelogram are perpendicular, then you know it's a rhombus. So you don't, let's say you have this quadrilateral, and you see a 4-sided figure, and you see the diagonals bisect each other. Excuse me, the bisectors are perpendicular. Then you know it's a rhombus. All right. Also, if the diagonals of a parallelogram bisect a pair of opposite angles, then it's a rhombus. So it's the converse of this one. This one is the converse of this one. This one is the converse of this one. You understand that? If one pair, so if you have this quadrilateral, not a parallelogram, you have this quadrilateral, oh, actually it would be a parallelogram. If you have this parallelogram and you say this side is equal to that side, those are consecutive sides. If you know that is true, then this is a rhombus. It has to be, because the other 2 sides have to be equal, because this side is congruent to this side, and this side is congruent to that side. Right? All right. The last thing is, if a quadrilateral is both a rectangle and a rhombus, it is a square. Okay? It is a square. But it has to be both, so I have to prove it both. Okay. You understand? All right. Do we need to take a picture of this video enough?
I'll take a picture.
All right, take a picture real quick. Send it out. While she's taking a picture of that, would you please turn page 466, page 466, please. You got her?
Yeah.
Okay. Page 466.
Simon,
Okay.
control.
If you heard Addie and I's discussion the other day, it was on this one. I'm going to be a little bit more specific than I was the other day. We're going to do 19, there's 19, 20, there's 4 of them, and they all have the same thing. Now, the last time was on the worksheet that I showed you this, and I said, okay, you got to finish it. Not all of you finished it.
No.
Some of you struggled with it. Okay, so let's take a look at 19. Read the directions to yourself as I read them.
What's the assignment?
Is this part of our assignment?
It is part of your assignment. It is part of your assignment. I'll get it to you in a second. It says, given each of the vertices, determine whether parallelogram JKLM is a rhombus, a rectangle, or a square. List all that apply. You do not have to graph it. If you prefer to graph it, take a kind of a piece of graph paper and look at it. Does anybody need graph paper? Okay. J is a -4, -1. K is 1, a -1. Make sure L is 4, 3. And M is,
Negative 1, 2.
thank you. Okay, now let me explain something to you. In order for this, it says that it's a parallelogram, right? And since we go in clockwise or counterclockwise, it does not matter which way you go. I know that this point and this point are opposite of each other. I also know that this point and this point are opposite of each other. So if I draw this, and I'm just going to draw it like that, if I go J, K, L, M, you can see that M and K are crossed in J and L. You understand? Those are the diagonals. Okay, the first thing it said is, determine whether it is a rhombus, rectangle, or square, and you should always start with the rectangle. Okay? We learned for today's assignment that a rectangle has diagonals that are equal. Right? So if the diagonals are equal, it's a rectangle. okay? You understand that? All right, so I'm gonna start there. I'm gonna start with a rectangle. I'm going to figure out JL. And the way I do that, the distance of JL is the distance formula. And I subtract the x's and I subtract the y's and I square them and add them together. So I'm gonna take the x's, which is a -4 minus 4 quantity squared plus a -1 minus 3 quantity squared. All right, you don't have to simplify these. Did I mess up? A -4 minus 4, a -1 minus 3. And it's both squared, right? So I have, if I change this, you ready? This is plus a negative, so I have the square root of a -8 quantity squared plus a -4 that quantity squared. And so I have the square root of 64 plus 16, which I believe is the square root of 80. Correct?
Yep.
Leave it like that. Leave it like that. All right. Now, I'm going to check Km. Km, the same way. The distance of Km is, and I do the distance formula. K is 1 minus a -1, quantity squared, plus a -1 minus 3, quantity squared, which I believe is the square root of 2 squared plus a -3 squared. So I'm getting 4 plus 9 squared of 13, is that right? Did I do that right? No,
No.
this should be 4, and that should be 16. So it'd be 16 plus 4, which is the square root of 20. Is that right? Much better. Okay, my bad. All right, are those diagonals equal?
No.
No, it's not a rectangle. So could it be a square?
No.
No. It cannot be a square.
It's a rhombus.
Well, we have to check. We don't know. We just know it's a quadrilateral. All right, here's the kicker. Here's the one we haven't talked about. We're going to talk about slope. Okay? Lines that are perpendicular. Here's the symbol for have opposite slopes. What are opposite slopes? I'm sorry. Yeah, opposite reciprocal slopes. Opposite slopes that are reciprocals. In other words, if you multiply them together, you get a -1. If you multiply them together, you get a -1. Okay? You understand what I'm saying? Okay. So if I say, okay, one has a slope of 2, what's its opposite reciprocal?
-1.
-1/2. Okay. All right. So what I'm going to do is I'm going to check JL and I'm going to check KM for their slopes. Okay. So JL, and I put a little m here. What does the little m stand for?
Measure.
No, it stands for slope. Remember, little m is slope in Algebra 1? Y equals mx plus b. Remember that? Right? Okay. So, it's a change in y over change in x. Okay? So I'm going to go J, L, right? So change in y, watch it, be careful here. It's a -1 minus 3 over a -4 minus 4. Is that correct? So this is plus a -4 over a -8, I believe, is 1/2. So what had I better get for Km in order for it to be a
1/2.
I better get 2, a -2,
Why
right?
is that be negative?
Because
It has to be the opposite.
Reciprocal.
So one has to be positive, the other one has to be negative. Okay? So let's do that. So let's do Km, capital M, and then little m for slope. So K is changing y's, and make sure you're doing the y's. A -1 minus 3 over 1 minus a -1. So I have a -4 over 2, which is -2. Guess what? All right? The diagonals are perpendicular, so it is a rhombus. Okay, now it could be neither. Could be neither. All right.
Wait, so we can't, so we still have to prove it even if we know it's wrong? This,
Yes.
like, if it's not-
Yep, yep, you do have to prove it. Yep, so you start with a rectangle. Never start with a square. There's no way you can start with it. Start with it, well, there is, but start with a rectangle, and if it's not a rectangle,
Then it's not
then it's not a square, and then you just have to prove whether it's a rhombus. Then what happens if it is a rectangle?
It's a square.
Then if the diagonals are perpendicular, then it could be a square,
And then you-
which is more specific than a rhombus. So it would be a rhombus and a square. Okay? So then it would be a rectangle, rhombus, and square. All of it. But it has to be both. Greeley, it has to be both a rectangle and a rhombus in order to be a square. Has to be both of them.
So pretty much we have to do everything.
Pretty
in
much.
order to get
Every
this.
time. Yep. Yep. Yes, dear.
So, can I just do it on graph paper and see?
You can do it on graph paper, but I have to have this.
Okay.
I have to have this, and that's why I didn't do it on graph paper, because I got people in here who do it on graph paper and said, well, you can just see that it's a rhombus, or you can just see, but you have to prove it.
Okay.
You have to show me that you prove it. All right. Any questions? So here's what I'm going to do. I'm going to change what I'm going to do. I'm going to give you the assignment, and I'm going to make it due Wednesday, and we'll just take one day for trapezoids and kites. So tomorrow's a work day.
Hallelujah.
So, well, yeah, okay. So, tell these guys that are gone, they'll be so mad at me, won't they? But if they get too mad, we'll just make it do. How's that?
Oh.
And you'll straighten them out, right?
Yep.
Yeah.
Tomorrow's 122, or 222, 22.
465, 7/2/14,
On the second day.
7/2. That's why we're taking a work day, because it's 2/2/22. It's Tuesday. My granddaughters are going with their little shirts that say Tuesday. Their grandmother got them shirts. Right, yep, shut it down.